Now we want to have a look at our index laws and review those. We've got a situation. Here's all the rules. Now you should remember all these rules and what an index is. You've been doing indices since year 7, and then we started to learn all our different rules that we had in year 9. So the idea that when we bases are the same and we multiplying, that we get the idea that we add the powers. Remember that if you're looking at what that is, that's a dot product. So just remember that one. So it's the same as multiplication. If we divide, then our indices subtract. If we've got the bracket here, then we're going to have to multiply our powers, because it's a to the m all the power of n, so it's a to the m n times, to multiply by itself n times. A to the power of 0 is 1. A negative indice indicates a fraction. We can also have this situation where product inside the brackets to the power of a number, then both of those numbers are to the power. Okay, now it's multiplication, not addition, so don't be fooled. If it's a plus b all the power of m, then it's different. Same for division, a to the power of a divided by b over m. We can put a power on both of those. And remember, when we get a fractional indice, it starts to indicate a square root or a cube root or a fourth root, or whichever root we would want to take there. So that's where the q comes from, and the p would be a power. So they're all the index laws we've done and you have to remember. So applying those ones. So remember, same base, we got the power of 9, power of 7, we're multiplying, so those would add. And then because we're dividing by 2, we subtract 2 from 16. 2y to the power of 4 all cubed, so the 2 would be cubed, and then the y to the power of 4 gets multiplied by the 3, so we get y to the power of 12, and so 8y to the power of 12. Doing our fraction, our indices here with some fractions, again we get to this point where we'll probably put it in the calculator anyway, so it's not too much of a problem. But leaving it as exact value, it's easier to put it into a fraction when it says an exact value there. And simple fractions, writing simple fractions when they're not in a fraction to start off with. Well, the negative indice indicates that it's going to be a fraction, so we write it 1 on 4 to the power of 3, which is 1 on 64. To the power of 2 thirds, all to the power of minus 4. Well, we can put it first to the power of 4 and leave it to the power of minus 1 there. So 2 to the power of 4 is 16, 2 to the power of 4 is 81, and that's left us to the power of minus 1 out the top. But what does that do to it? It takes the reciprocal for us. So putting something to the power of minus 1 when it's already a fraction, we'll put it as a reciprocal form for us there. 157.49 to the power of 0. Well, anything to the power of 0 is 1, so it doesn't matter what number it is. Anything to the power of 0 is 1. So again, to the power of 2 times x to the power of minus 5 is 2 on x to the power of 5. Then minus negative indice indicates we put a fraction. We put it in a fraction. Now this one's one where we've got to be really careful and knowing the difference between these two, because notice the 2 stays on top because only the x to the power of minus 5, not the 2. So I often see students write it like that. They start to bring the 2 down with it, but the 2 is not associated with it. It is here though. Be seen though, we got the brackets all the power of minus 1, so that's where it goes 1 over 2 to the power of x, because everything in the brackets is to the power of minus 1. The same thing here, x minus 1 to the power of minus 2 gives us 1 over x minus 1 all squared, so the whole thing goes over because it's in the bracket. So be really careful, know the difference between these two, because that one would not be correct, because the 2 has to stay on top because it's not to a negative indice there. Taking the cube root, so remember 8 to the power of 1/3 would be the same as writing the cube root of 8, which again you can throw in your calculator if you're not too sure. Again, you can do these ones on your calculator, but that's really saying 1 on the cube root of 125 all squared. So that's what that one's actually saying, because the negative makes a fraction because it's power of 2, so it's 125 squared, and the 3 in the denominator indicates that's the cube root there. So that's what that one means. But again, you can throw that straight into your calculator. Now your calculators are very good and able to do that nowadays. Writing an index form, 3x minus 1 with the square root there means we put it to the power of a half. And without without the fractional indices. Again, the negative indicates a fraction. The 3 makes it x cubed, and the 2 there would mean the square root. So that's our indices. We have to be able to play around and especially go between these types of forms. We're going to be doing a bit of work with these types of things in calculus as we go along, as well as using our fractions and doing addition and subtraction of fractions with our indices. So that will be something we'll need to be really good at before we get to calculus. So we're not having to worry about it with calculus. The other thing we want to look at in this video is about scientific notation. Again, something you've done before. And why do we use it? Well, for very large or very small numbers. So we don't want to have to write out really large or really small numbers. We want to have a simplified way of doing that. So what we want to do is we want to put a number that's really large or really small into this form. And it's a number times 10 to the power of another number. So, but there's certain rules we've got to follow. This first number a here has to be between 1 and 10. And then n has to be a whole number. So what we call an integer. So if you're not too sure what an integer was, integers are whole numbers. You'll see that come up more and more in the course. So 10 to the power of an integer with a number out the front. So between 1 and 10. So it can't be a less than 1. It can't be more than 10. Or it can't actually be 10. It's got to be less than 10. It can be 1, but it has to be less than 10. So writing these ones in scientific notation. So if we're looking at 68,000, well, we can see, well, our number we have to have is 6.8, because the number we're going to write is going to be between 1 and 10. How many decimal places do we move to do that? And that tells us how many we put in our power. So we moved our decimal place 4 places to the left there, so that was what it would be 4. 720,000, well, again, we go with the 7.2 there. And we've moved 5 decimal places, so we get 10 to the power of 5. Notice really large numbers will have positive indexes there. So that's a key. We're not going to have a negative index for a really large number, because a negative index will indicate a fraction. So 93 million, again, move your decimal point to the 9.3, because that's between 1 and 10, and we've moved it 7 spots. 4,206,000 comes 4.206, and we've moved it 6 decimal places. So really this is the key, is just realizing, okay, once I've got my number here from between 1 and 10, how many decimal places am I moving it? So, and it's just a matter of counting them up. 3, 6, 8. We're going the other way. Again, we've got to get a number between 1 and 10, so this time our decimal places are moving this way. So we need 6, or 6.0 if you like, and we've moved it 2 decimal places to the right there, so it's become -2. So 7.564, and we moved 1, 2, 3 decimal places. So notice that negative indice indicates a fraction that we have to have there. 4.12, again we've moved 3 decimal places. And you can see the other ones there, how we've got to move and get our number between 1 and 10, and then move our decimal places accordingly. Some problems you're going to face with it, and it's just really just calculations. Your calculators will often put it in scientific notation. Sometimes it will, sometimes it won't. It might not put it exactly in scientific notation. Keep remembering when you put that in your calculator that you have to write it. That first number has to be between 1 and 10. So we're writing this correct to 3 significant figures. Again, the 3 is the first significant, 5, and then 3. But because it's 7, it goes up to 4. And then we've moved it 1, 2, 3 places to the left, so it becomes 10 to the power of 3. Again, taking it this way, 32.8609 to 3 significant figures becomes 3.29. So because we cut it off there, the 8 goes up to 9. We have to move our decimal place once that way, because we have to get this number between 1 and 10. So there we go. That's how we get put our answers in scientific notation. So if you follow those rules, you shouldn't go too far wrong. But remember, you're going to see problems where you're going to bring in significant figures, decimal places, and things like that. So it's about interpreting what the problem's saying and also making sure that we don't make those simple errors, because this is classic areas where we make those simple errors.